Hi and I welcome you to this video. In this video, I am going to explain you about what is hashing. Hashing is the process of compressing or reducing a dataset of arbitrary size into a fixed size. What does it mean? Here arbitrary size means a variable size. So for example, if you are hashing an input dataset of size 10 MB, the hashed output dataset size will be 512 bits, which is 64 bytes. Next, if you pass an input dataset size of 20 MB, even now the hashed output dataset size will be 512 bits. As you can see here, hashed output dataset size will remain same for variable input dataset size. Well, now let's see why we need hashing in the first place. The need for hashing will change based on the use cases. Now here I will talk about few major use cases. First, let's talk how hashing is used for fast data retrieval. There are two data structures that you can use when you want to make search and data retrieval faster. The one is array and the other is hash tables. In arrays, we store and retrieve data using an index, which is an integer. It's the position of the data in an array. In most of the programming languages, we have a data structure called hash table, which basically stores data in key value pairs. For example, in Python we have dictionaries and in Java we have map. Let's understand this with an example. Consider a library where the details of the books have to be searched from a data structure. Of course, the book count in library will be huge, and the best data structure to use for fast data access is array. The one drawback in array is we have to access data directly through index number for fast retrieval. So here we bring in hashing to achieve this. The output dataset of our hashing should be an integer, which is lesser than our array size. And we will use this integer as our array index, where we will be storing the details about the book. Later, when we want to search for a book, we will just do the same hashing to book name, and we will find the index number where the details about the book is stored. Then we will fetch the details by directly accessing the index in array. By using array, we are introducing a complexity of reducing the book name into an unique integer, which can be used as array index to store and access the book details. If we don't want to deal with this complexity, then the best way is to use hash tables. Here, our key will be the book name and the value will be the book details. But it's best to have a fixed length of string as key in hash table. So we will do a simple hashing with book name as input dataset and will get a fixed length string as output dataset. While storing book details into hash table, the fixed length hash string will be the key and the book details will be the value. Later, while retrieving the details about book, we will just do the hashing on book name to get the key, and we will access hash table by passing the key to get the value, which is details about book. The next use case for hashing is when you want to distribute your data as clusters, you can go with hashing. For example, let's consider we are storing a huge volume of data into a data center, and we don't want to store all of our data into a particular set of storage racks. Basically, we want to uniformly distribute our data across all available storage racks. Here, we can do hashing to equally distribute our data across storage racks based on the hashed output dataset. In this case, our hashing should return rack ID of one of the available storage racks, and the data should be stored in that particular storage rack. And also, the hashing should be done in such a way that data is uniformly distributed across racks. The next use case for hashing is when we want to check data integrity. After downloading data over network, we can check if packets are tampered in the middle by using hashing method. The sender will find the hash value of the packet that has to be sent over network. Then both the packet and the hash value will be sent by the sender. On receiving the packet, receiver will find hash value of the received packet, and this hash value will be cross-checked if it is same as the hash value sent by the sender. This is how we can use hashing to check validity or correctness of the file or content which is downloaded over network. I think now you got a basic understanding on hashing and its use cases. In my next video, I will talk about hash function, which is the backbone of hashing. For now, I conclude this video and let's meet in my next video. If you like my videos, hit subscribe button and bell button to get notifications about my uploads. Thank you.